Alright, in this video I'm going to do another partial fraction decomposition example. And here we've got 2x plus 9 over x minus 2 times x plus 1 times x plus 2. Actually, in this example we've got an already factored denominator, so that would make our lives a lot easier. But since we've got three pieces in the factors, or three parentheses, three factors, then we also need, as a result, three partial fractions, a, b, and c, and each one would take one piece of the three. So x minus 2 would go to a, and x plus 1 would go to b, and x plus 2 would go to c. Sorry, here it's just I was running out of space. But anyway, so basically, like we did the last time, to get rid of the denominator, we multiply, but I simply just multiply by whatever the denominator is. So we multiply this side with x minus 2 times x plus 1 times x plus 2 to get rid of the denominator on this side. But then whatever I do on the left side, I got to do on the right side. So I multiply the denominator by the partial fractions, plotting all to all the partial fractions, each piece here. And in this, if x minus 2 times x plus 1 times x plus 2 times a over x minus 2, we simply get rid of the x minus 2 would go with this, and we're left out with a times x plus 1 times x plus 2. The same would go in b and c. So each one will get rid of the denominator, and we're left out with the two other pieces. Again, that's how our equation would break down. So we got rid of the denominator, we're left out with the numerator on this side, 2x plus 9. And here, how we got to that, as I said before, for the a, we just distribute the denominator on both sides. So on this side, we distribute all the denominator to each piece. So in a, we got rid of its denominator, but we left out with x plus 1 and x plus 2, so a times that. Same thing for b, we got rid of the denominator, we left out with the two other pieces or terms, b times x minus 2 times x plus 2. The same thing for c, we got rid of the x plus 2, its denominator, and we left out with x minus 2 times x plus 1. And now what I basically do is use my little rather trick, which is find appropriate values for x to find each of the unknown, which is a, b, and c. So in that case, we've got three values for x. We're going to try them each time. So to equalize a and b and c to 0, then we have to find the good values for x's. So for this one, the first option, might want to minimize the camera. So the first option is of x is x equals to minus 1, x is equal to minus 2, and x equals to plus 2. I'll show you why I chose these values for x right now. So now what I basically do is just substitute every value of x, the three values each time, to the original equation. So for the first one here, let's try x equals to minus 1. So if x is equal to minus 1, so basically what I'm left out here is 2 times minus 1, which is minus 2, plus 9 on this side. And for a times x plus 1, if you plot minus 1 here, we're left out with a times minus 1 plus 1, which is 0, so the whole of a would turn to 0. So we got rid of a. B, we're going to plot, before b, if we plot in the same thing we plot in c, we got rid of c, because it will all go down to 0, because we've got minus 1 plus 1. So only we're left out with b. So basically what we've got here is a times 0 plus, and for b times minus 1 minus 2 which is minus 3. So it's going to be b times minus 3 times x plus 2, and here x we've got minus 1 again. Minus 1 plus 2 is 1, so anything multiplied with 1 is it just itself, plus again c here would be times to 0 because we've got one of the parentheses is 0, that multiplied with c is 0, so the whole thing would go to 0. So basically left out with this. Minus 2 plus 9 is 7. We've got it here, equals to, we only left out with b, so a times 0 and c with 0 cancel each other out. So b times minus 3 is minus 3, and times 1 is itself minus 3, so we're left out with minus 3b. So basically we've got 7 equals minus 3b, it's just a simple linear equation. So b equals to, get rid of that, we get 7 over minus 3. So that's the value of b. So we substitute that in the original partial fraction of b here. Substitute b with 7 over minus 3. Again, we do the same for the other two values of x. We substitute. So we've got here x equals minus 2. We plot in that in the original equation that we've got. So if x is equal to minus 2, then 2x plus 9 would turn to 2 times minus 2, which is minus 4, plus 9 equals to a. Again, a would turn to 0 because in the in this term that multiplies with a, we've got x plus 2, so minus 2 times plus 2 is 0. So the whole thing would go to 0. So we got rid of a. Same thing for b here. Minus 2, we plot in that minus 2 in this times b would go to 0 times b. So the whole thing would c. We're only left out with c. So c times minus 2 is minus 4. So we're left out c times minus 4 times minus 2 plus 1, which is minus 1. So we literally just simplify that. After simplifying this, we get minus 4 plus 9 is positive 5. And minus 4 times minus 1 is positive 4. So left out with 4 times c is 4c. So in that case, c would equal to 5 over 4, and that's the value of c. We literally substitute c 5 over 4 with the original equation here, partial fraction. So c would substitute that with 5 over 4. Now the last thing we're going to do is find a, and to do that we need to plot in the last, or the other, the third value of x equals to 2. Again here we substitute x equals to 2 to the original equation. So on this side we're left at 2 times 2, 4, plus 9. So that's 4, positive 4 plus 9 equals to a times 2 plus 1, right, because we've got x equals to 2. So a times 2 plus 1 is 3. So a times 3 times 2 plus 2, which is 4, times 4. And for the rest of the equation, we get 0, because if we plot in 2 here, we get b times 2 minus 2, which is 0, so the whole thing would turn to 0. Same thing for c, 2 times minus 2 is 0, so whatever multiplied with c is 0 as well. So only left out with a. So again, we simplify here, just a simple equation. 4 plus 9 is 13. And for a times 3 times 4, 4 times 3 is 12, so we're left out with 12a. And here, if you simplify it to make a on its own, we get a equals to 13 over 12. and that's the final answer for A. So what we basically did is just a quick recap on this. We get rid of the denominator, and before that actually we try to factor this side, and then we get rid of the denominator, and we literally equalize all the factors with 0 to get each unknown A, B and C on their own, so we can find the solution for them. And then after that you rewrite the partial fraction. After you get the values for A, B and C, you rewrite it and plot in and substitute whatever you've got for A, B and C with the original partial fraction.